can react, right? But let's cut this salt thing into several parts. Okay. So we will have like thousands of pieces. Are you getting this? We have
Yes, sir.
thousands of pieces which have got exposed with the, you know, with the other thing, so that it can react, right?
Yes,
Understood?
sir.
Huh. So this one is also quite logical. Kindly note this down. One can easily understand that sugar powder will easily dissolve than big sugar cubes in water. So this is just because of increase of surface area. Done?
Yes, sir.
Yes. Okay. So let's see the fourth point, which is not much popular, but you have to know this also, that since like some reactions are photochemical reactions, intensity of light. So since they are photosensitive reactions, photo means light, photosensitive reaction, that therefore what will happen as we increase the intensity of light, means as we increase the number of photons on that chemical thing, as intensity increases, ROR, rate of reaction, will increase. And a very popular example is H2 plus Cl2. We will revisit this example again in near future. H nu is light, which is, you can say, photon. So photon is striking on this H2 and Cl2 mixture, gaseous mixture. And what is happening? This HCl is forming, okay, in gaseous form only. Got it? So this is highly dependent on this intensity of light. Understood?
Yes. Yes, sir.
Huh. Next, oh, next is catalyst. Have you ever heard this name, catalyst?
Yes, sir.
So catalyst is a substance which speeds up the rate of chemical reaction. Okay, what's happened? What is actually happening is it's setups. alternate path from reactant to product. See what I have written. What is a catalyst? This is the actual definition. That is, basic definition. Which you may know that catalysts are a substance which are speeding up the chemical reaction. But what is actually happening here is it is setting up an alternate path or easy path. Okay, from conversion of reactant to product having lower activation energy. So let me draw a graph for you. However, if if you're not getting it fully, no problem at all, because in the last lecture or second last lecture, we will discuss this thing only. This activation energy, catalyst, what is actually catalyst is doing, what is happening, and all. So what is catalyst doing actually? It is setting up an alternate path and lower the activation energy. See, this is a reactant. This is energy versus this time. So what is happening? We have to reach from reactant to product, right? For a reaction. So in real life, what happens? Without catalyst, a reactant have to go and reach to a certain level of energy. Okay, this is called activation energy. I will not define it for you to confuse you. Activation energy. Okay, so what is catalyst doing? It is lowering this point. Lower the activation energy, more will be the speed of rate of reaction. So this is an easy path for reaction to follow from reactant to product, and this is like a big mountain to cross, and this is a small mountain to cross. You can understand here by like this. Okay, are you getting this? No problem if you're not getting the graph. But you have to understand this. Yes, catalysts are doing something like setting an alternate easy path to speed up the reaction. Okay.
Yes, sir.
Any question?
No, sir.
Okay. So this is an example. You can leave the example if you want. NO is acting as a catalyst here. Okay. That is why you will not see NO in the product side. NO is applied is there in the solution in the reactant side. However, it is not a part of the product. And here ROR is directly proportional to concentration of NO. Okay. So we can comment that yes, catalyst affects the rate of reaction. Done?
Yes, sir.
Hmm. Yeah.
Yes, sir.
Now finally we have temperature. Temperature. So the general thing is, since this is not true for all reactions, that is why we are writing generally. Generally, ROR increases on increasing temperature. Okay. So just note this down. Generally, rate of reaction increases on increasing temperature. Can you guess why? Anyone?
Because the reactants burn faster.
Yeah, the random motion, or the collision of the reactant particles have increased. That is why. Okay. So note this down. Like on 10-degree rise in temperature. Actually, this question comes not directly. That is why I'm you know letting you write is in note. On 10-degree rise in temperature, rate of reaction increases 2 to 3 times. This is general thing. Okay. And when we will study like in Arrhenius equation in this chapter later, the last major topic, the formula is K A e की power minus E A upon RT. So T is the temperature arrow, and K is the rate constant. So from this equation also, one can say yes, the rate of reaction is dependent on this temperature thing. Okay. And how it is, see, if you can see by math, as temperature will increase, so this whole thing will decrease, right? Since it is in denominator. Okay. This will decrease now as
Yes.
temperature increases. So the whole value of this will decrease. But since it has minus sign, so this will overall increase. That is why K will also increase. Got my point?
Yes.
Note this down. We will write final thing and the major thing, the most important one. And we will do the continue the discussion from there only. Numbering is 6th. Done.
Yes,
This
sir.
formula is very important, but not now, because means we cannot understand this formula yet. The last class, sorry, later we will understand this formula. So the most important one is concentration of reactants. Concentration of reactants. So first I will write the points and start writing with me because there are some points. Let me know when you are done, and then I will start explaining. Done?
Yes, sir.
Sana?
Yes, sir.
Okay. So what we can see here, what I have written here, generally rate of reaction increase on increasing temperature. Increasing concentration. But this is not always true. That is why we have taken different cases that like decreasing our rate of reaction could decrease on increasing concentration, means they are inversely proportional. As we are increasing concentration, rate of reaction is decreasing. Okay. Acha, these things which we have written here are observed experimentally. Okay. some rate of reaction does not depend on any type of concentration. It may concentration is increasing or decreasing. It does not affect the rate of reaction. That is why we have written rate of reaction remains unaffected. Like for example, since I've told we will revisit, we are visiting this one. Okay. As you can see, when we increase hydrogen or chlorine concentration now, it is not depending the rate of reaction of HCl, formation of HCl. It is only dependent on the how much intensity of light is falling upon the this mixture, gaseous mixture. Okay. So in the from this reaction, I'm giving you live example that yes, with the concentration, with the concentration, there is no effect in rate of concentration, rate of reaction. Are you getting this?
Yes, sir.
With the concentration of H2 or Cl2, there is no effect in rate of reaction. But rate of reaction is proportional to H nu, which is intensity of light here. Got my point?
Yes, sir.
Uh, you got my point, Rishita?
Yes, sir.
This the square bracket denotes concentration. Since you're in class 12, you may know this means. So you means Harshita, you are having doubt. I can repeat, no problem.
So me?
Huh.
No, sir. I'm fine.
Okay. Okay. So this is a good example that yes, ROR is not affecting the are not affected with the concentration of this reactants. So and this last one, that rate of reaction is can be dependent on one or all or none of the reactants concentration. Like for example, there are A plus B plus C is giving D plus E. So rate of reaction could be dependent on A and B. Okay, like A and C, but not on B. So this is also possible. Are you getting this? This is not necessary
Yes.
that if the reactants, rate of reaction is dependent on concentration of reactants, but it can pick and choose also. Means it is dependent on experimentally that rate of reaction is depending on every reactants or not. Okay, got my point?
Yes, sir.
Yes, sir.
Huh. So so to understand this point, to understand this issue, we have to go to the next topic, which is known as rate law. Which is known as rate law. So what does rate law say? Acha, acha, you may have written this now. Okay. Rate law. So rate law will actually tell you that on how they are uh, affected by this reactant side. Okay. For example, let me write definition first. So we are continuing this only, concentration of reactants. or the rate of reaction is depending on the concentration of reactants. So we will to solve the numericals, we have to understand the mathematical expression and all. So it explains the dependence of rate of reaction on concentration of species in a reaction. Is it? So we have to understand the mathematical expression. The mathematical expression in terms of concentration of reactants called rate law expression. So the big thing what we have to understand here is what is rate law expression. Okay, and let me give you with example we will understand it better. Like for example, 2A is reacting with and giving C. Okay, and by experiment we have seen what we have seen here. As we doubling the concentration of A is one of the reactant, the rate of reaction is also doubling. Okay, it also doubles. Okay, so we can comment that rate of reaction is proportional to A. Acha, can you people observe that the stoichiometric coefficient here is 2, but here we are rate of reaction we are writing it like proportional, directly proportional to A, not 2A or A square. Why? Because it is experimental. Rate of reaction which comes is always experimental. Means we cannot explain it in theoretical form. It is always experimental. Or rate of reaction is changing with the concentration of any reactant is always experimental. So this is a good thing, and we will get data in the numericals, and we have to just apply the data. Okay. And with the consent, let's assume that we are doubling the concentration of BOs. So what we see here, that rate of reaction means increases 4 times. Increases 4 times. So we can comment that rate of reaction is proportional to square of the concentration of B. Why? Because we are doubling it. Okay, we are doubling it, and the concentration is increasing 4 times. So this must be the square of this concentration. Got my point? Like for example, just for the example sake, if we are, doubling the concentration of A, and we see that rate of reaction becomes half हो गया, means it decreases. Okay, so we can say that rate of reaction is proportional to A की power -1. How? That we are, doubling the rate of reaction, concentration of A. A concentration is doubling and rate of reaction becoming half. So obviously there should be a power of -1. Got my point?
Yes, sir.
So this rate of reaction, the dependency of rate of reaction on the concentration of reactant can be anything. Got my point?
Yes, sir.
This is just for information. That is why I am keeping it here. Means don't mix up things. So you can write it later. So what we can say that see, this the first point, rate of reaction is proportional to A and rate of reaction proportional to B square. So what we can say finally, that rate of reaction is proportional to A and also proportional to B square, concentration of B square. Okay, so we will replace it with K B square. This will be the rate of reaction of this above reaction, and this expression is only called, this expression is known as rate law expression. Rate law expression. And what are these? Let me write in more general form. What are this P and Q? P and Q are, no, I will write it separately. Wait. What is P and Q? P is order of reaction, with respect to A, right?
Yes,
Q
sir.
is order of reaction with respect to B. What is K here? K is rate constant. Why it is constant? See, we have replaced this proportionality sign. So when we replace proportionality sign, one constant comes. So K is that only. Okay. And ROR is obviously rate of reaction. I'm not writing. Okay. So every term KQR, yes. And the most important one, P plus Q. P plus Q is the most important thing which you have to understand, order of reaction. Order of reaction. So after this, adding the coefficient of the concentration of reactants, the order of reaction comes. Okay, got my
Yes, sir.
point?
Yes, sir.
So first solve a simple numerical, then you can write it later. Calculate order of reaction. Reaction. Whose this question is in came in 2020. This is easy. I mean, like whose rate law expression according to experiment. Experiment से ही आएगा, means we cannot theoretically we cannot say, it always dependent on experiment. The experiment is ROR given as K NO3 So let me know the rate of the order of reaction. Find out the order of reaction. What is the order of reaction? Message in chat. Harshita. Harshita means sorry.
Yes, sir.
Rishita. Are you feeling sleepy?
No, sir. I'll send the answer.
You have 15 seconds. Done?
No, sir.
What are you doing? We have the formula here for order of reaction in this only. Can you see?
Yes, sir. It's one. Order of reaction is one.
It is 2 actually. See, it is very simple. Order will be this. Sum of this and this. No, sum of the power of the reactants. That is it in the rate law expression. If rate law expression is given, you don't have to worry about anything. Just add them. 3 by 2, 1 by 2 means you will get 2 obviously. 3 plus 1 upon 2. 4 by 2 is equal to 2. Okay. Rishita,
Yes, sir.
understood?
Yes, sir. I understand.
Huh. So order of reaction, this order of reaction is denoted by N, okay? And please remember that order of reaction with respect to A or B or the order of reaction, they all can be, you know, positive, negative, can be fraction, okay? As we have seen in the this below question, there this was fraction, right? It can be anything. It can be zero, okay? Got my point?
Yes, sir.
And obviously, when we add those, n can be also anything, positive, negative, fraction, zero, right?
Yes, sir.
Yes, sir.
Ha. So this is not like this stoichiometric coefficient that you will get integer. No, it can be anything. Why it can be anything? Because it is wholly dependent on experiments which we are doing. So it is directly experiment dependent, so it can come anything. Okay. So please note it down. Which from where you want to note it? Can you tell me? From here?
Yes, sir.
Huh. My writing is terrible today. Kindly write it first. See, I'm writing rate of reaction with respect to this another case. This was case 2, in which uh, we are doubling the A, but we are getting the rate of reaction half. Okay. So what will be the final rate of reaction? Rate law expression A minus 1 B square, right? Yeah, Rishita and Zaina.
Yes, sir.
B as see B1 is here and A we are getting minus 1. So this will, what will be the order, Rishita?
Uh, so it's 1.
1, good. So you understood. Acha, can you note these down fastly? We have to do 2-3 questions. Done with the purple one, Rishita
Yes.
and Rana. Okay. Done.
Yes, sir.
Yes,
ऋषिता,
sir.
हाँ बोलना था ना. I'm giving you a question from NCRT only. Try to solve this. We will solve.
Are you screen sharing?
Wait. Try this question. First, read out this question. Okay. We will try it together. Uh, a reaction is first order in A, means it is giving first order reaction with respect to A, and the reaction is second order with respect to B. Okay, this is already given. Okay, and what we have to find the differential rate equation. We have to find the differential rate equation or rate law expression. Okay, the mathematical rate equation. Second is how rate is affected on increasing the concentration of B, and it is increasing the temperature concentration 3 times of B. And let's try one by one. So first of all, the question is given first order with respect to A, right?
Yes, sir.
So we can say that a rate of reaction is proportional to A power 1, right? Rishita,
Yes, sir.
are you getting this? And second order with respect to B. So we will have 2A, right? So what will be the rate law expression or differential rate equation? Rishita, can you say this? Rishita,
Yes,
you
sir.
are sleeping. What is rate of reaction here?
A raised to 1 and plus B raised to 2.
Not plus, it is multiplying. Okay.
Yes.
Good. So finally, ROR will be equal to K. So are we good till here? We have done the first question. Okay. Now,
Yes.
Zana, what is the order of this reaction?
3.
Means this is nothing. Okay. 3. 1 plus 2 is equal to 3. Right. So we have taken out the order. Uh, so second question, how is the rate affected on the increasing the concentration of B 3 times? Can you people means comment on it directly without means me telling? Means you can tell it by yourself also. Matlab, just guess. Try to guess. Means we are try to understand. We are increasing the concentration of B 3 times. I'm asking how much rate of reaction will increase?
So will it be K into A raised to 1 and 3B raised to 2?
No, you have to tell me like it is increasing 2 times or 6 times or 8 times or 10 times.
So, sir, for concentration of B, we should consider that it has already been increased 3 times and then it's being doubled again.
It is not doubling, it is squaring, right? So
Okay,
let
but
me
then the concentration is still 3 times.
try it for you. Okay, this is the first time, no problem, don't worry. So R is, for example, we have R initial A, A, B, right? We have R final as we are taking a ratio of them. Okay, R final as K, A. We haven't touched the concentration of A, right? So we will leave it. Okay, kindly respond.
Yes, sir.
Yes, sir.
And we have increased the concentration of B 3 times. So B will become 3B. Okay,
Yes, sir.
Are you getting this? Okay. So what will happen? This will cancel out because they are same in both of the reactions. So Ri upon Rf. This is initial. This is final. B is concentration and 9b square. So this will is also equal. So what we are getting here is this thing. Are you getting this?
Yes, sir.
We have taken the ratio of both of them and we cancel out the same one and we are getting this also. Jana, have you understood this?
So will the concentration of A also not become squared because it's also get
No,
doubled?
no, we have where it is been doubled. How is the rate increased on increasing concentration of
In
B
the third
3
part?
times? We have not in this question, we are not touching A, but in the next question you can see that the rate of what we have to find out, the concentration of A and B both are doubling. So there we will do that. Okay.
Yes, sir.
So see, I'm doing it for you. The rest you can do it by yourself. So this is the first one. First one is this. Second one is this. Third one. Third one will be rate of reaction. Ri. Same thing. Upon Rf. A times. What we will write here in place of A?
A square.
A square, not A square. 2A na. A is becoming 2A na.
2A.
हाँ
2A and 2B.
हाँ 2A. And it is becoming 2B, but it has a square on it. Okay.
So will it be like
So,
1 by 16 times the actual?
16, not 18 na.
So 4 into 4, right?
Oh yes, 2 to the 4, 4 to the 8, 8. 2 to the 4, 8. Let me show it. If you are having trouble, and the moment you understood it, just let me know. Got my point?
Yes, sir.
Okay. Understood, Zaina?
Yes, sir.
Okay. So you are comfortable with this?
Yes, sir.
Try this out. This question. Question given is the reaction is second order reaction with respect to a reactant. How is the reaction affected if the concentration of reactant is doubled and reduced to half? Okay. So there are also two parts given in the question. So here the reaction rate is second order. Okay. Are you getting this? So directly we will write it as let's as like this, right? Tell
Yes,
me,
sir.
Rishita.
Yes, sir.
So now what is it is saying? How is the rate of reaction affected if the concentration of reactant is doubled? So let's try to solve this. So Ri, you can try it also in your copy notebook. And Rf, I'm not completing this. Write yourself. Look, this one is little unique. Kindly look second part. So you can do this, but still I'm letting you know, because you have to solve a lot of question. I will give you an homework. Okay, I would like you to try them out. Okay, the questions which I will give you an assignment. Okay? So A is reducing to half. So what I will write in the concentration part?
A by 2.
Anybody? A by 2. Good. So now there is only mathematical part to solve, right? You two people can do this, right?
Yes, sir.
So you will get the right answer. Just note these down. This is also from NCERT. From where you have to you have done this, na? Noted down this, na? This thing.
Yes, sir.
Okay. Kindly note this. Have you understood today's lecture? Means any doubt?
No,
No,
sir.
sir.
Zana, what you were saying?
No doubt, sir.
Ajay. Okay. Kindly note down these steps. Hello, Jaslyn. Please wait for a moment. They are just copying these down
Okay, sir.
for a minute.
I'm done, sir.
Done? Zana?
Sir, the other question, will it be in the assignment?
Yeah, obviously. I will just give you those questions only which you can do. Okay. So
No, sir. After this, the question which we just did.
this is
This
a very
one.
short question. You can do it by yourself. You already did. You have done this question, right? By yourself.
Yes,
Na?
I'm done.
So, okay. So thank you. You two people can leave. Okay. Thank you.
Thank you.
Assalamu alaikum.
Thank you, sir.
Hmm. So, Jaslyn, where are we? You have doubts, right? We have to discuss some questions. Hello.
Sir, I was told to join this link at 9 o'clock.
No. It will be 9 o'clock. I was teaching another batch.
No,
Chemical.
my time at my time zone.
Okay. From your एक minute. Wait a minute. So, are you free or not? Means, are you able to continue?
Yes, sir.
Okay. एक second. So which topic? First, take out that thing. This chapter. Classification of elements.
Okay,
Are you
sir.
there? And I have seen your paper. You have done means multiple mistakes. You have doubt in theory or what? Means you can tell me, no problem.
Sir, I didn't study that chapter for the test properly.
Okay. So and now means after like sometimes people study after test also. Means before test, there sometimes they do not get time or some other reasons. So have you tried to solve them after test?
Yes, sir.
Okay, this is a good thing that after test you try to solve the questions, like what was asked in the exam. Can I attempt that, or where I lagged? So good. Uh, please continue, Alina. So shall I this 3 and 4? Can you see the question?
No, sir.
Without question, how we will discuss? Huh? Alina. Alina, what is your name? Jesslyn. Sorry.
Jesslyn.
So see, the first question was like it was asking about European. So it's okay, you forgot, but you can guess it, right? Like you should learn each and every element from S and P block. There may be a confusion in D and F, but you can cross two options now, right?
Yes, sir.
Uh, so what you are seeing currently, your copy or test copy? Means what you are saying means what do you have now?
Sir, mine.
Yourself. Okay, okay. So the other last the second question was this increasing order of radii, right?
Yes, sir.
See, uh, where you have confusion in this? Means no. First, tell me, since you revisited it, uh, you shall ask those questions which you are still in doubt, right?
Yes, sir.
So
Um,
because there are some very easy questions which you need not to check out, but there are some good questions, but you may have revised, so you don't need to cover this. So it will take time from both of us. Jaslyn,
yes, sir.
what happened? Jaslyn,
So one second, I'm finding for the question paper, but I can't find it.
have you done? Let's discuss if you have. You are okay with this question? Calcium ion and this potassium ion and sulfur ion.
Yes, sir.
Okay, okay, okay. Good, good, good. See, next time, just be prepared and choose those questions only which you want to discuss, right? So this will be very means great benefit to you,
Okay,
right?
sir.
If you want to discuss from chemical bonding, we can discuss that also. Means if you have something in your mind, no problem.
One second, let me open it.
Ah, there is some time crunch only, but this is the only issue. There are many questions which you have done wrong, like Acha, is this okay for you? This one, H plus, H minus, and H. This one, atomic radii.
Yes, sir. So
So,
for the chemical bonding one,
and then you first comment on this one,
um,
atomic
so I
radii.
redid the MCQs of the question paper, the MCQs before I redid it.
No, you don't need to read it. Just I'm asking you a question. You have to answer it. You have to tell me the radii order of H plus, H minus, and H.
The radii order.
Yeah, radius order.
So H minus will come first.
Okay, it is biggest or smallest?
The smallest.
Okay, then
Wait. No, H plus will come first. Then
on which criteria you
H.
are putting anything lesser or more? What is your criteria?
There
Because
are number of electrons.
number of electrons. So on increasing number of electrons, size increases or decreases? And why increases or decreases? See, why will come always in chemistry, okay? Especially in organic chemistry. So try to answer that. If you have conceptual problem, no problem. You can discuss with me. It's okay. But if you linger around like here and there, so it will not help you and me also. You have done this also wrong. Calcium, boron, beryllium, and lithium. Order, size order. Hmm? See, let me tell you. This as we go toward the right of the periodic table, now start concentrating here. Okay, Jaslin.
Yes, sir.
So as we start going left to right in the periodic table, you understand? This is the periodic table.
Yes, sir.
Yes. So as we move left to right, size. What happens to size?
Size increases.
Size
Increases.
increases. Why it increases?
So the radius of the atomic radius
Yeah, atomic radius.
from left to right, it decreases.
Why? In the both option, you have to answer why.
Because of the number of electrons present in each atom.
So size is increasing or decreasing?
Size is decreasing.
So number of electrons are adding or means, what is your reason behind that answer?
Because the outer electrons on the same valence shell and the
See, are you Googling this or what?
no, sir.
So this is means you cannot find this, means you can find it on Google, but you have to read a proper some 2-3 paras. But let me tell you, I will tell you in one or two line. And since we are means interacting now, so I will make you understand what is happening as we move left to right now. You understand Z effective? Z
Sir, I
effective,
forgot. Sir, effective.
shielding effect,
Yes, sir.
screening effect.
Yes, sir.
So can you tell me what it is?
For shielding effect, the numbers of electrons that is in the outermost shell, they
Uh-huh.
don't experience like a full positive charge.
Good,
So
good,
like
good.
they are screened away from the nucleus.
So your answer is 95% correct. Okay. So you know it. So we have to rebate, in every periodicity thing, na, like ionic radius, like atomic radius, like electronegativity, like electron affinity, है ना, ionization energy, everything we somehow connected with Z effective. You have the understanding of Z effective, right? You're not just mug up it. You understand it, right?
Yes, sir.
Huh. So what is happening is like this is two electrons, right? We have, let's assume we have one electron here. Okay. So what is happening is these two electrons, let me show you electron here. It may be more helpful for you. So these two, this is pulling the electron, right? Nucleus is pulling the electron. Okay.
Okay, sir.
And these two electrons are pushing the electrons or pulling the electrons? Repelling the
Well,
electrons or
repel.
attracting the electron? Yeah, repelling the electron. So what is happening is that this is not getting the actual Z or actual positive force of the nucleus, right? So this is called Z effective, or let me tell you, this is called screening effect. Like they are screening it. Okay, they are making a screen, right? Or they are shielding the this nucleus from this electron. Okay, so shielding and screening, same thing. Okay, same definition, exactly same. Okay,
Okay, sir.
and this nucleus is made up of proton, right?
Yes, sir.
Okay, and you may know that number of proton is equal to what? Z. We represent it by Z, right? In atomic chapter, in that chapter, structure of atom, you may have learned this is called Z. Okay, so how much effectively it is pulling, how much effectively this is pulling is called Z effective. Okay, so the Z effective will be always lesser than Z, right? This is, it has been reduced by this repulsion of these inner electrons, right? Got my point? Uh, Jesslyn, where were you?
Sir, I got disconnected. So sorry.
Okay. Everything good now?
Yes, sir.
So tell me. You understood this point?
Yes, sir. Screening effect.
Screen, and you understood Z effective or not?
So can you? I think I missed that. Can you
Okay,
repeat?
no problem. No problem. I am repeating. So number of proton is equal to equal to Z, right?
Yes, sir.
It is denoted by Z. Like Z is equal to 1 is hydrogen, Z is equal to 2 is helium, Z is equal to 3 is beryllium. So the pull should be equal to Z, but here the pull is lesser than Z, right? It should be equal to Z, right? Like if we have 10 protons, 10 protons should be pulling this electron, but here because of these electrons, the effective pulling is like lesser than 10 electrons, like 9 protons or 8 protons, right? Are you getting my point?
Yes, sir.
So Z effective is lesser than Z. It denotes the actual pull, which is actual pull which is felt by this electron. Okay, got my point? You means, have you feel this?
Yes, sir. Understood.
Understood this?
Yes, sir.
You can write this definition also. Net means net positive charge. Net positive charge experienced by electron. Okay, got my point?
Yes, sir.
Experienced by electron. Experienced by upcoming electron, right? Oncoming electron, which is just away from. So what see the trend which we are talking about, that's the most important thing here, that as we move from left to right, what is happening? Are you there?
So can you repeat?
Well, I'm saying that as we are moving left to right, Z effective is increasing. Okay, why it is
Okay, sir.
increasing? Why it is increasing? As number of Z is increasing, right?
Yes, sir.
Number of electron is also increasing, but number of this Z is increasing. Okay, so as
Okay.
Z effective is increasing, can we say that atomic radius will reduce? Atomic radius will reduce. Why? The pull is increasing. Since pull is increasing, right? You can write this down as pull. The pull of electron increases. You can understand, right? The radius will decrease. Are you getting my
Yes,
point?
sir.
As pull will increase, the radius will decrease, right?
Yes, sir.
Good. So this is the most important thing here. Understood?
Yes, sir.
Now let's comment on this hydrogen one. Let's comment on this. So I think you can do this. Like carbon is here, beryllium, boron is here, lithium is here, and beryllium is here. So obviously this will, what will happen? This will decrease the radius, right?
Increase.
Got my point? Always when you hear the word about size, ionic or this atomic, just check for Z effective. That is it. Okay.
Okay, sir.
And as we move down, the radius will increase, right? This is very
Yes, sir.
easy. Let's check for this. This is also important. H plus, H minus, and H. Okay. So what is happening? What is happening? Let's feel with this क्या नाम है? Diagram. So first is H. Second is, you have to comment on it. Please be focused. Okay. We have 2 electron here. This is H minus, right? This is H, and this is no electron here. Means no, nothing is present here. I'm not drawing electron here. This is H plus. So can you see this is H, this is H minus, and this is H, right?
Yes, sir.
And now you have to comment that which is bigger and which is smaller.
First will be
Think by Z effective. And there are other logics also. Just use your brain.
H
You have
minus.
no, just don't guess it. Just first use your brain, because I'm going to ask you why. Okay. So what is your answer? Which is at least tell me which is bigger, or which is biggest, or which is smallest. Just anyone, anything.
The smallest will be H plus.
Smallest will be good. You are correct. Very much correct. Good, good, good. Now next answer.
Then the neutral H.
Neutral H. So your answer is correct. Yes, there are 2 electrons, so they are repelling. They are, and they have only 1 proton is dealing with those 2 electrons. So they are a greater repulsion. So this size is great. This size is nothing. It has only 1 proton, right? I'm just faking it for you, just for understand. So your answer is correct. Alina, good. Are you getting this?
Yes, sir.
So why you are in tension? What happened, Alina?
The Jesslyn.
Wrestling?
Jesslyn.
Oh, sorry. Uh, you have done one more question wrong. Very easy question. Which this is the orbital nearest to nucleus, right? So option was 4F, 4S, 4P, and 4D. Okay. So you marked 4F. Answer will be S. Okay, 4S. Why? This S orbital is like this, right? So they are more closer to the nucleus. P is this, right? P is this, right? So they are more far. They are very close. Okay. Just remember, S orbital is the closest to the nucleus. Okay. Hello.
Okay, sir.
Ask 1 or 2 question more, because time is, I have to go to another batch also.
Yeah,
Ask,
ma'am.
ask some question if you have any important question. Hello. So, Jaslin, you can take another class also. And Jaslin, hello.
Yes, sir.
I would like you to try them out first, okay? And collect those doubts and ask those doubts. And first, I would like you to, understand the whole concept of this trending ones. Trending means this periodicity thing, okay?
Okay, sir.
And I know that you will get some doubts. No problem, I'm here, okay? The most important thing which I have taught you is Z effective. You have to use that concept in that periodicity thing, because it is, it will come frequently. Like most of the periodic things are dependent on that thing. Okay.
Okay, sir.
And we will discuss then. There are a lot of questions, so you may first do the periodicity thing, then you can do that